In this video, we're talking about how to solve fractional equations where we've got numbers and letters all mixed up in the equation. Really, this is no different than solving a fractional equation when we just have whole number fractions and one variable. Notice here that we have the same equation. First, we're going to solve it for p, then we're going to solve it for y. But the equation is 6 over p minus ax is equal to m over y plus k. So as always with fractional equations, our first step is going to be to eliminate the fractions. Once we have the fractions eliminated, then we'll go ahead and solve for our variable. In order to eliminate the fractions, we have to multiply through the entire equation, all the terms on both sides, by a common denominator for all of the fractions. Well, we've got two fractions involved here. We have 6 over p and we have m over y. So we need to find a common denominator between those two and then multiply both sides by that common denominator. So our common denominator is just going to be py, or p times y. So what we want to do is multiply through the entire equation by py, and when we do that, we'll distribute this py across every term on both the left and the right hand sides. So py times 6 over p, the p's will cancel because we have one in the numerator and one in the denominator, and we'll be left with only 6y. Then we're going to say minus axpy is equal to, here we have m over y times py. The y's will cancel because we have one in the numerator and one in the denominator, leaving us with only mp. And then when we multiply py by k, we'll get plus kpy. Now we need to go ahead and solve this for p, and in order to do that, we need to collect all the terms that involve p together on one side, putting all the terms that don't involve p on the other side. So the only term that doesn't involve p is this 6y, so we want to get that by itself, which means we need to move this negative axpy to the right hand side. So in order to do that, we're going to add axpy to both sides plus axpy, and when we do that, we'll get axpy to cancel on this side because we've got a negative and a positive. So then we have 6y is equal to mp plus kpy plus axpy. From here, we'll go ahead and factor out a p on the left-hand side because every term involves p, so we'll get 6y is equal to, factoring out a p, we get p times m plus ky plus axy. So we just pulled a p out of each one of these terms. Now, all we have to do to get p by itself is divide both sides of the equation by this polynomial here, m plus ky plus axy. If we divide this right-hand side by that polynomial, we'll get p by itself. So our final answer then is going to be 6y divided by m plus ky plus axy, and that's going to be equal to p. Now we're going to follow this same process no matter which variable we're solving for. So we could also solve this equation for y. We want to do the same thing. We want to find a common denominator and multiply both sides by the common denominator for all of the fractions in the equation. And of course our common denominator is still py. That doesn't change anything. So when we multiply through by py, we're going to get the same thing we got before. 6y minus axpy is equal to mp plus kpy. Now remember, we're trying to solve this one for y, so that means we want to get all of our y variables together on one side and any terms that don't involve y by themselves on the other side. The only term that doesn't involve y in this equation is mp, so we want to isolate it over here on the right hand side by subtracting kpy from both sides. When we do that, we'll get 6y minus axpy minus kpy is equal to mp. The kpy will disappear on this side when we subtract kpy from the right. So now we have mp by itself. We have all of our y's over here on the left. We just want to factor out a y like we did before. So factor out a y and we get 6 minus axp minus kp is equal to mp, and now to get y by itself, we just divide through both sides by this polynomial because that'll leave us with just y on the left. So we'll get y is equal to mp divided by that polynomial 6 minus axp minus kp. If you wanted to, you could also solve this equation for a, or for x, or for m, or for k. You would just still multiply by the common denominator to eliminate the fractions and get the equation to this point, and then you'd isolate whatever variable you were looking to solve for, whether that was a, or x, or m, or k. You'd get that term by itself alone, just like we did here for p, and just like we did here for y.